Explorer 1, NASA's farthest voyaging shuttle, proceeds with its surprising venture through space, delightfully sending important information from the most profound districts of the universe. For almost 50 years, this exceptional space probe has changed our understanding of space. However, recently, the spacecraft has been sending disturbing information back to Earth, leaving the whole space industry in shock. Are these agitating pieces of information the consequence of a technical breakdown or the actions of extraterrestrials? Join us as we uncover the truth behind these stunning transmissions. Since the very beginning, researchers have been dazzled by the secrets that lie beyond our divine lines. This curiosity prompted the notable launch of the Explorer 1 and Explorer 2 rockets, among other surprising space missions. These notable missions, which have been studied for a long time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that very year, Explorer 1 followed suit. These twin probes, each weighing a significant 720 kilograms, comparable to a small vehicle, were propelled into space during an extraordinary arrangement of the outer planets. Throughout their fantastic odyssey, these gutsy adventurers explored different directions and speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outperformed its indistinguishable twin due to variations in their paths. From that point onward, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's frightening new discovery that stunned the entire space industry, let's explore the astounding images captured by the shuttle during its earth-shattering Jovian imaging mission in 1978. Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it sent a stunning number of photos back to Earth. In January 1979, it embarked on an unprecedented 100-hour attempt, capturing hypnotizing time-lapse film showing 10 turns of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's grand dance in clear detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, where it made a surprising discovery: the presence of a humble ring surrounding Jupiter, along with 2 new moons. These findings were drawn out into the open, further expanding our understanding of Jupiter's exciting domain. To ensure safe entry and prevent a potential crash with Titan, one of Saturn's moons, remedial moves were executed. Explorer 1 continued its divine journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, and Dione. With the completion of the Saturn mission, researchers decided to close the Explorer planetary mission, moving both Explorer 1 and Explorer 2 beyond the bounds of our planetary system, jumping through space at a shocking velocity of 325 million kilometers each year. In January 1990, a new chapter began with the Explorer interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, deifying the Sun and most of the planets. One person who played a crucial role in expanding the missions beyond their initial targets was the famous astronomer Dr. Sean Artley. As part of the Explorer mission's imaging team, Artley championed the idea of capturing one final set of pictures, a farewell gift to humankind. Against all odds, his persistent determination bore fruit. On February 14, 1990, Explorer 1, positioned 6 billion kilometers from the Sun, set out on a visual excursion, commonly known as the family picture, to capture what is now known as the iconic portrait of our solar system. These amazing pictures, totaling 60 in number, added to the shuttle's impressive collection of 670 photos. During its encounter with Neptune, Voyager 2 achieved an unprecedented accomplishment by recording wind speeds exceeding 13,100 miles per hour, making it the fastest wind ever recorded within our planetary system. As the shuttle wandered within 280 miles of Neptune's purplish-blue methane-rich atmosphere, it provided extraordinary insights into this distant celestial body. Remarkably, Neptune's largest moon, Triton, was revealed as one of the coldest objects in our solar system, with surface temperatures plummeting to a frigid -391 degrees Fahrenheit. Triton's strange features, such as its nitrogen gas-spewing ice volcanoes that launched cold particles 5 miles into its tenuous atmosphere, further captivated our imaginations. These phenomenal revelations expanded our understanding of the vast variety and complexity of celestial objects residing in the farthest reaches of our solar system. But don't go anywhere. Explorer 1's space apparatus has recently made one of its most startling discoveries in the entire history of space exploration. Let's find out what it has accomplished in the last 45 years. The accomplishments of the Explorer twin probes have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left analysts in awe and shattered previous assumptions about these distant worlds. These moons, once thought to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several remarkable feats during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Just 3 years later, it achieved another pivotal milestone with a flyby of Neptune. To this day, it remains the only spacecraft to have undertaken such a journey. As the Explorer spacecraft continued its voyage, NASA implemented various measures to extend its operational lifespan over the years. Unnecessary parts and heaters were deactivated to conserve energy, ensuring that these brave travelers could continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this extraordinary project from the very beginning, the end of the Explorer missions is both a moment of pride and a hint of sorrow. Their unwavering dedication and tireless efforts have far surpassed their original expectations. The wealth of data returned by the explorers has provided crucial insights, fueled numerous scientific discoveries, and sparked the imaginations of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary spacecraft. They were meticulously designed as stable platforms with a rotation rate more than 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the spacecraft captured images and data while soaring through the vastness of space. Even before their encounters with the outer planets, their remarkable imaging capabilities began to astonish scientists and the public alike. The spacecraft began transmitting pictures of Jupiter long before reaching the gas giant. These early images, showing swirling clouds and the iconic Great Red Spot, thrilled audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals from Io, which were confirmed by the distinctive images they captured: towering volcanic plumes and a surface scarred by volcanic material. One of Io's most prominent volcanoes, Pele, erupted with a force several times greater than Mount Everest's height, covering an area nearly the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it's important to note that the photographs they captured did not include Mercury and Mars for various reasons. In addition to the Explorer 1 and Explorer 2 interstellar probes, NASA has also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Explorer 1 passed Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solo journey for another 14 years before finally entering interstellar space on August 25, 2012. Although there were no other spacecraft in sight, NASA did not publicly announce this remarkable achievement until 2013. What strategies were used to ensure the success of the Explorer missions? One technique stood out as truly brilliant: gravity assist maneuvers. These maneuvers played a pivotal role in propelling Explorer 1 and Explorer 2 on their daring journey to explore the outer reaches of our solar system. To reach these distant destinations and gather crucial data, the spacecraft required more than just their own propulsion systems. They needed a boost. Gravity assists provided just that. Imagine the two brave spacecraft, Voyager 1 and Explorer 2, setting out on their grand tour through the solar system. Rather than relying solely on their engines, they performed a celestial dance with some of our solar system's heavyweights. This intricate maneuver allowed them to harness the immense gravitational pull of these giants to slingshot themselves along their way. In doing so, they saved precious fuel and gained the speed needed to visit multiple destinations. Let's dive into the basics of gravity assist, also known as a gravitational slingshot. The idea behind this maneuver is to transfer some of a planet's momentum to the spacecraft as it passes by. Imagine Explorer 1 approaching Jupiter, a massive gas giant with a gravitational force to match. Explorer 1 passed Jupiter at the perfect point in speed, allowing the planet's gravity to pull the spacecraft, accelerating it to a higher speed and providing an interstellar boost. Performing a gravity assist requires extraordinary precision. If Explorer 1 had approached Jupiter at the wrong point or speed, the slingshot could have resulted in a misalignment of its intended course. The level of accuracy needed is overwhelming. Nonetheless, the brilliant minds behind these missions successfully executed these gravity assists numerous times, propelling the Explorer spacecraft on a stunning journey through the solar system. For example, Explorer 2 used gravity assists from Jupiter and Saturn to reach Uranus and Neptune, two icy giants that would otherwise have been far beyond the spacecraft's reach. However, gravity assists do have their limitations. They can only take the spacecraft so far. After reaching the outer reaches of the solar system, Explorer 1 and Explorer 2 no longer had massive planets to help them speed along. To continue their voyage into interstellar space, they had to rely solely on their own momentum and the energy provided by their radioisotope thermoelectric generators. These generators, which convert heat from decaying plutonium into electricity, allowed the spacecraft to keep transmitting data for decades. But as the spacecraft moved farther from the sun, they received less solar energy, and their power supply began to dwindle. Despite this, both Explorer 1 and Explorer 2 continued to send valuable data back to Earth, long after their expected missions had concluded. Yet, what happened after they entered interstellar space, and what startling discovery has been made recently? An odd series of unexpected signals recently stunned researchers. The latest transmissions from Explorer 1 have baffled space scientists, who cannot explain the source of the strange data. Could they be the result of a technological malfunction? Or are these signals the result of something far more mysterious? Could Explorer 1 have discovered something entirely beyond our comprehension? Perhaps evidence of extraterrestrial intelligence? Or is it a product of the natural mysteries of deep space? As Explorer 1 continues to send back data from the farthest reaches of space, the scientific community remains captivated by its journey. After all these years, the mission's longevity and its ability to provide groundbreaking information about the cosmos have surpassed even the most optimistic expectations. The latest transmissions, however, have thrown scientists into a state of uncertainty, sparking debates about whether these signals point to a technological anomaly or an entirely new discovery. The signals themselves are unlike anything seen before. When Explorer 1 entered interstellar space in 2012, it transitioned into a realm where the solar wind no longer dominates, and the deep void of space presents a different kind of cosmic radiation environment. At this point, any signals sent back were expected to be routine. Data about cosmic background radiation, magnetic fields, and the solar system's outer regions. But the latest signals have been inconsistent, containing frequencies that don't align with anything previously recorded by the spacecraft. Scientists have begun investigating whether these signals could be the result of unforeseen electromagnetic activity within the spacecraft itself. Some speculate that the radioisotope thermoelectric generators, RTGs, may have experienced a malfunction, affecting the instruments and causing unusual data transmission. However, the fact that the signals appear to follow a consistent pattern over several months suggests that they are not random or a result of a malfunction. This has led to even more tantalizing speculation. Could these signals be pointing to an extraterrestrial origin? Some researchers are now entertaining the possibility that Explorer 1, after almost 5 decades of travel, has stumbled upon something beyond our understanding. An alien signal, perhaps emanating from a distant civilization or a previously unknown astronomical phenomenon. The thought of the spacecraft uncovering evidence of intelligent life has captured the imagination of many. While such a hypothesis is still in the realm of speculation, the idea that extraterrestrial intelligence might be trying to communicate with us is a tantalizing notion. In the absence of definitive explanations, the scientific community has proposed a variety of theories. One theory suggests that the strange signals might be a form of communication from a distant alien race, which may have developed technologies beyond our current understanding. Another possibility is that these signals are the result of the spacecraft encountering an unknown natural phenomenon, such as dark matter or a unique form of cosmic radiation that has yet to be discovered. These signals could also be indicative of a previously unknown object or structure in space, possibly a massive, unseen anomaly that the spacecraft is now interacting with. Despite these theories, it's important to acknowledge the challenges scientists face in interpreting the data from such a distant probe. The signals are faint, and their transmission is often interrupted by the vast distances involved. Additionally, the spacecraft's instruments are not as advanced as those on newer missions, which could limit the ability to fully decode the signals. Nevertheless, the fact that Explorer 1 has managed to continue transmitting data after such a long time in space is a testament to the ingenuity behind its design and the dedication of the engineers and scientists who have kept the mission alive. As the investigation into these mysterious signals continues, scientists are also looking at the broader implications of the mission's discoveries. Explorer 1 has been a key player in expanding our knowledge of space, revealing details about the outer planets, their moons, and the very nature of the universe itself. Its contributions to our understanding of the Jovian system, Saturn's rings, and the interstellar medium have been invaluable. Each new piece of data it provides adds a layer to the vast mosaic of space exploration. At the same time, Explorer 1's journey raises broader questions about the future of interstellar exploration. What more might we learn as the spacecraft continues its silent trek through the stars? The ongoing discoveries from the spacecraft highlight the importance of long-term space missions and the need for sustained investment in space exploration. The mysteries of the universe are vast, and missions like Explorer 1 remind us of the endless possibilities that lie ahead.